So I will be presenting this concept without Tahani, unfortunately. A lot of noise. Okay, so first, I think it's interesting to move from Ifat's presentation and to shift from imagination in artistic memory to imagination in scientific memory, which would be part of my presentation now. And I must say that this is the first time that I present these topics, so it's very new and experimental and edgy for me. Okay, so I will share my screen with you. Just a second. Do you see it well? I need some indication. Do you see my screen?
Yeah, we see. Okay.
Okay, great. So I begin with this photo where you can see an open card box, palm size, and in it a hand-written sticky note. Next to it, pinned to a foamy white surface material, as you can see, is a preserved specimen of a bee with a tiny label and a barcode. On the sticky note, the German handwriting translates to test animal to focus the camera. Must be determined every once in a while and put in the appropriate box. What needs to be determined or calibrated is the focus, and what needs to be put in the appropriate box is the bee after calibration is done. It is a focus bee, a little type specimen of what we propose to call DATANATUREs. The off-white background is the plastic laminated tabletop in the digitization hall situated in the first floor of the Museum für Naturkunde in the Natural History Museum in Berlin. In the foreground, you might be able to notice my shadow leaning forward with my phone to capture this image. I took this while visiting the digitization hall with Tahani Nadim, the co-author of this talk, and also my host professor during my stay as a postdoc in the Humanities of Nature department in the museum. Together with two other colleagues, we toured the digitization hall, which is located next to the central hall featuring the dinosaurs. The test bee in charge of the focus is put inside the conveyor belt driven imaging system, which, as we were told, is hoped to be digitizing up to 5,000 specimens a day. Here you can see the conveyor belt. So the museum recently received public funding for a large-scale digitization of its collections, which includes more than 30 million specimens. And this planned as a 10 years project, the future database that it creates promises to democratize access, produce engagement with the collections for scientific and public purposes, and position the museum at the forefront of a data-intensive research in the natural sciences. The museum in Berlin is not alone in this. Many museums around the world are currently pursuing large-scale digitization projects. And as researchers in the humanities and social science department, our premise is that mass digitization of collections is anything but 10 years project. It is rather a socio-technical transformation that is going to change the future of research in the natural sciences and beyond, reshaping the way we understand and conceive of nature. So DATANATURE is an open proposition rather than a coherent concept that describes a well-studied phenomenon. It suggests to pay critical attention to the emergence of the datafication of nature on a global scale and engage in examining its meanings and its potential social and political consequences. The datafication of nature is tightly related to global biodiversity data. In contrast to the term biodiversity that emerged in the early 1980s in relation to rising environmental concerns, global biodiversity is a recent invention and depends on recording and digitizing human observation of natural phenomena such as geotagged smartphone photos and mass digitization of natural history specimens collected in the past 200 years, ranging from specimens, seeds, tissues, blood samples, to genetic data, behavioral data, as well as archival documents, field notes, sound bites, and more. What is at stake here is knowing what is the Earth's biodiversity, what species are there, and what are the population trends across time and space. This is important because species biodiversity is dramatically affected by human-induced climate change and has been linked with planetary health and social health. And so globalizing biodiversity knowledge is crucial for framing climate change and biodiversity loss as a global problem for global governance. But representing biodiversity as a global phenomenon through a data-driven science also presents new kinds of problems. As Esther Turnout and other critiques show, it creates a problematic circularity where global biodiversity databases create the world they seek to describe and act upon. The globalization of biodiversity through centralized databases creates a specific kind of decontextualized knowledge oriented for global policymaking. As a result of the requirement to be policy relevant, global biodiversity data infrastructures stand the risk of being prescriptive and performative, representing global biodiversity as much as constituting it. It can be argued that nature has been replaced with biodiversity, and the creation of an inventory of life on Earth has been turned into a data-driven exercise. The science studies scholar Jeffrey Boker wrote as early as 21 years ago that the database itself will ultimately shape the world in its image. It will be performative. Boker shows how biological taxonomy and nomenclature, the naming system for classifying life on Earth, is always biased and partial. Some species are hard to classify because they are scattered or have fuzzy boundaries like algae. Others are overclassified because they are more charismatic than others, such as pandas, tigers, or butterflies. And others might not be classified at all. As Boker writes, if we are only saving what we are counting, and if our counts are biased in many different ways, then we are creating a world in which those counts become more and more normalized. Such a data-driven world is easily normalized as what there is, standing the risk of rendering all other species or diversities invisible or lost. The way we propose it, DATANATURE is not limited to natural history and natural sciences. It takes the datafication of nature as an analytic to think of how different domains engage in world making through data practices. We can see similar patterns of circularity and performativity in urbanism and militarism, for example. So looking at the smart city as a cloud of computing, Orit Halpern and colleagues show how the aggregation of data for predictive analysis collapses into self-referential production. Because in order to predict the future in the smart city, its systems must always use past data. Similarly, Ian Shaw describes military drones as a new emergence of non-human aerial sovereignty that takes shape through the extensive capturing, coding, and cataloging of information on people's lives. It facilitates the profiling of individuals within a population based on identifying patterns of life, and on this basis, predicting dangerousness before danger is actualized. Another recent example is Joey Bolomwini's research, who discovered that the datasets through which most facial recognition systems are tested contains 78% male faces and 84% white faces. Only 4% were women and dark-skinned. While algorithms are creating a world in which dark-skinned women are invisible, as Bolomwini shows, these data and technologies are imagined as objective and neutral. As Lisa Gittelman and Virginia Jackson show, data is not simply a matter of techniques, technologies, and computers, but rather of imagination. They write, data needs to be imagined as data to exist and function as such. And the imagination of data entails an interpretive base. To follow on this quote, I want to take the last few minutes I have to say a few words on what the history of natural history teaches us on the nature of data and its imaginative and interpretive base. So the life of biological information took off in the late 18th century with the invention of taxonomy by the Swedish botanist Carl Linnaeus. Natural history since these early modern times became most explicitly devoted to data management. The desire to create an inventory of all life on Earth became a logical and systematic mission by ordering complex taxonomies that allowed to quantify species information. The early emergence of this desire to represent life on Earth on a global scale was inseparable from colonial and imperial ways of seeing and forms of exploitation. Linnaeus included humans amongst the taxonomies of animal species and divided them into categories based on physical appearance and behavior. These classifications were later enhanced by others through hierarchizing racial types, commonly with white Europeans at the top and Africans at the bottom. These early classifications were setting the stage for the development of racist scientific disciplines such as eugenics and physical anthropology. Museums as the databases of natural history were instrumental in legitimizing these racist ideas in collections, in labels, and more broadly in scientific thought. While racist disciplines were officially disregarded as non-scientific after World War II, recent examples of racism, sexism, and other forms of oppression in algorithmic classifications remind us that data ideologies are here to stay. To sum up, what we are arguing for by creating the hybrid concept of data natures is that the datafication of nature is not only a representational practice, it is a creative world making. It can be complicit with dominant positivist discourses of big data, claiming that opening access to research data in global databases will create new kinds of knowledges that would deliver us from the need for interpretation, analysis, or pesky ethical decisions. But it can also open opportunities for various critical and politically conscious forms of world making. Our test B, undocumented worker, was put to calibrate the focus of a digitizing machine in a grand experiment. As a focus B, it is a new kind of hybrid specimen in the museum. Now it can be classified as a specimen in the new formations of data natures. The production of knowledge and the doing of science are always entangled with questions of positionality and situatedness. Question as to whose knowledge, whose science is being opened, by whom, who benefits, who's left behind. All these questions need to be part of the discussion. Not only, they need to be part of the technological work that prototypes data-driven futures. This is not only because we need the critical humanities to unpack forms of domination in science and technology, but more importantly, because we need to reimagine new data ideologies that are anti-racist, anti-colonial, and intersectional that would be embedded within technological environments, that would be embedded in our future performative and world-making data infrastructures. Our critical participation within technological environments is crucial for coding our imagination into our data infrastructure. In that sense, we should take an example from the test bee and actively engage in these practical realms. Thank you.